Hello, thank you for checking out Team 1 Consulting's final video presentation for Minidesign Project 2. Just some quick background for those of you who may have forgotten from our previous presentation, but the idea behind our project was to design a can crusher for music festivals such as Veld, because of the mass amount of garbage that's left behind in these festivals. We had two primary objectives. One, to crush a can to 1/5 its nominal size, and the device had to be powered solely by renewable energies. Our secondary objectives were to be user-friendly and to crush a can within 30 seconds max. We really wanted our design to fit seamlessly into the festival ecosystem. We had this in mind throughout all of our conceptual designs. We decided we could fix solar panels to sun umbrellas and use the umbrella rod as the housing for our crushing mechanism. For this course, we wanted to build a proof of concept that would show the idea is feasible. The main components in this design are the solar panel, charge controller, battery, microcontroller, linear actuator, and crushing chamber. Some key calculations were determining the size of a solar panel that would be required for Ontario-based festivals. We needed to size our battery for our linear actuator, and our linear actuator's force was required to crush the can is based on the number determined from the original can crusher patent of 900 newtons. One note is that we changed from 3D printed ABS plastic to 3D printed PLA plastic because 3D printed PLA plastic has a higher yield stress. We went ahead with our first prototype, and we had issues with the print quality as well as with the angle of the base. We tried to have an angle of the base so we could have automatic ejection of the crushed cans, but this presented a problem, as cans tended to slide out while being crushed. With everything that has happened in the last couple months, we were faced with a decision. Test out our newly calculated angle that would reduce or provide the amount of friction required to keep the cans from sliding, or to scrap the whole angle idea outright and print a flat base so that we know we would have a working prototype. We knew the printing lab was closing soon, so we decided to go with the flat bottom to avoid having another failed part. We knew that the angled bottom was not the biggest concern for our project. We decided it was time to verify that we had designed these components adequately. We did some simulations to determine if the design could withstand the can crushing force. We found that these designs' maximum stress was 16 megapascals, which was far below the yield stress of 3D printed PLA. You can see the stress concentrations right around here and here, which is consistent with what we learned from our machine elements course.
Let's show you what we got here. So we got our 20-watt solar panel that has a 12-volt output, which comes to our charge controller, where we control basically what's going on with the solar panel battery and the load. So we have a 12-volt battery connected to that, which then powers this H-bridge here. So this H-bridge is what controls the linear actuator. It controls its speed and direction. We have it at max speed and change in direction depending on what we do with the switch. Now that's all coded in the Arduino script that's then programmed into this Arduino. And basically this whole circuit just runs off this simple switch here, which again is improvised due to the fact that we haven't had any access to any resources in the last couple weeks. Me and my roommate have been social distancing. Also, again, up here, we're holding the linear actuator down with zip ties. That was not what was supposed to happen. That's a result, again, of social distancing. This is some of the highest quality engineering material you can find around the house. Just crushed this Budweiser, supposed king of beers, debatable. This is much better. We're going to crush this with the king of can crushers. So we'll put that in there. We got the door here, which we close for safety purposes, but you know what? We don't need safety today. I really want you to see the crush in progress. So we take our high quality metal strip that's not a bolt, it's a switch, and we just pop it right in here to engage the crusher. Now we'll remove that, allow the can crusher to disengage, and what we have is a crushed can. I don't know, that looks like 1/5 the volume to me.
This semester definitely presented itself as a opportunity for learning, and a couple lessons that our team has identified and acknowledged is to continue to fight procrastination. You never know what the clock actually is going to do. You don't know how much time you really have left, and so by fighting procrastination, we're able to actually get the project done, even though things did change. Another one is don't fear the unknown and move outside your comfort zone. This one really is key because none of us had really any knowledge of electronics or coding, and stepping outside our comfort zone and trying to build something that would push for growth was something that really stuck out as a good lesson to continue to keep. Avoid rigidity in ideas. This one is just about having an open mind and not sticking to your first idea, and being open to hearing other ideas from different teammates. And lastly, succeed as a team and not as an individual. It's not about how you do, it's about how the team does.